Hello everyone, in this video we're going to be talking about a different topic. We're going to be talking about let's say the change of a double integral over, let's say, an enclosed area. Okay, so we know that we can use double integrals to find the area of a closed curve. Okay, specifically this red marked one. Anyways, the topic is not about actually finding the area itself, because you can evaluate this and get the value. Okay, even though here we can just say the f of x function is 1. Okay, or it can change, it doesn't really matter. Anyways, so today we're going to be trying to find an equivalent integral to this. In other words, this is dy dx, so we're going to be integrating with respect to y and then x. We want it the other way around, so basically dx dy. Okay, and then this doesn't change. Okay, then first we're gonna be having the limits in terms of x if we change that. So this becomes x equal to, and then the last one becomes y equal to something. Also, one more important thing, when you use integrals to evaluate measurements or find, let's say, areas, volumes, arc length, things like that, the last integration, or let's say the limit, the lower and upper limit for the last integration has always to be just numbers. Okay, so in the inside one could be numbers, could be variables, could be functions, it doesn't matter. But the last two, or let's say the last two limits, lower and upper limits, should be always numbers, as the same way this has x equal to 0 and then this has x equal to 4. Okay, now to figure out, so the only thing that we need to figure out is these four values. Okay, now before we do anything, when first this was constructed, it was constructed like this. So we're actually figuring out the dimension for y. Okay, so it was constructed like this. So they started from below, because that's where the negative values of y start. And then, so they're moving like this. The first thing they encounter is this curve. Okay, so what is this curve? So actually, since the lower limit is y is equal to the square root of x, so this curve is actually okay, so I think this question was supposed to be the other way around, even though it doesn't matter because we don't accept negative values. Okay, so this is like that. Okay, it's the same thing. Okay, so the first curve that we encounter and we hit first is this, which is basically 1 over 2 x squared. Okay, so this curve is 1 over 2 x squared. And then when we enter the area, okay, the last thing we're going to be touching is this other curve. Okay, and this other curve is 2 the square root of x. Again, you might be wondering, how did I know? Well, it's given because the lower limit is this, because the first curve that you hit, and then once you go out from the curve, you're going out through this curve. So basically this is 2 the square root of x. Okay, and then what about these two numbers? How did we put them? Well, imagine these two markers. Okay, so horizontally, the area, the first, let's say the initial point of the area is this red marker, and then the terminal point is this. So you can imagine it as values of x. So this is obviously x equal to 0, and this is x equal to 4. Okay, now we just figure out how this is done, so that we do figure out our part. Okay, so this time first we're going to be moving horizontally. Okay, so like this, I'm going to be starting from left like this, going to be moving. Okay, so what curve did I hit first? This one. Okay, so I hit this curve first. So basically the curve where y is equal to the square root of x. But again, I want a value of x, not a value of y. So if I solve this equation in a way that x is separated, I can get a function of that is x of y. Okay, so How do I do that? I have a square root. I square both sides, so this becomes y squared 4x. And from then I can divide both sides by 4, so x is equal to y squared over 4. So this lower limit is y squared over 4. Okay. What about the upper limit? Well, when I enter the area, I'm gonna be leaving the area through this curve, which is it is actually given. It's 1 over 2x squared. Okay, so y is equal to 1 over 2x squared. And again, if I just adjust the equation in a way that I get x. Okay, so I actually can again square both sides, so this becomes y squared. This becomes 1 over 4. Actually, no, it's the other way around. So I want to get rid of the power, so I'm going to be taking the square root of both sides. So this becomes the square root of y, and then this becomes 1 over the square root of 2, and then this becomes x. And now you might be asking yourself, well, do I get a plus or a minus number for here? Well, we're dealing with the right side of the x-axis, so obviously it's a positive. Okay, it's the positive part of this. Okay, now just multiply both sides by the square root of 2, so you can actually get this nice equation. So x is equal to the square root of 2y. So the square root of 2y. Okay. Yeah, and then we're going to be leaving through that curve that we just found. Okay. Now for the vertical part, I'm going to actually erase in this so that we don't get confused. Okay. Now again, we're starting from below. Okay, so like this. Okay. But this time, since we're finding numbers, or let's say finding a frame, okay, you have to think about the whole area as a rectangle. Unless you do that, you will make a mistake. Okay, for the second limit, which is just numbers, draw a frame around the area, and you're good to go. Why am I doing this? Well, because once I enter this rectangle, I'm going to be hitting this part of the rectangle. Here, y is obviously 0. Okay, so y is 0. Now I'm inside the rectangle. I'm going to be leaving the rectangle through this line, which is just y is equal to 4. Okay, so that's y equal to 0. That's y equal to 4. Okay. So basically, these two integrals are equivalent. If you find, let's say, the value of this curve through this or that, they should be the same.